Welcome to the Explainer. Let's just dive right in and demystify the secret code of sheet music. Did you know your brain actually processes reading music a lot like it processes a spoken language? It's pretty amazing. So today, we're going to take that language and map it directly onto the physical geography of your violin fingerboard. Consider this your masterclass in the fundamentals. We're taking what looks like an abstract grid of lines and spaces and turning it into physical, muscle memory movements that just make perfect sense.
To get there, we'll be following a clear roadmap today. Section 1, decoding the musical staff. Section 2, meet your violin fingerboard. Section 3, the magic of fingers. Section 4, half steps and whole steps. And finally, Section 5, connecting staff to strings.
All right, Section 1, decoding the musical staff. Let's start building our map by exploring the Mr. Smith patented way to decode the 5-line treble staff.
Now, I know the staff can look like a dense, confusing grid at first glance, but it's really just a ladder that tells you exactly how high or low a pitch should be. And our foundation? It all begins by memorizing that the note D lives directly underneath the first line of the staff. Think of this D as the absolute ground floor of our musical building. It just hangs out right there below the bottom line, acting as our steadfast anchor. If you can find this one D, you can literally figure out absolutely everything else on the page. Because from that anchor, you simply count up the lines and spaces using the standard musical alphabet. So, moving from that D underneath the staff up to sit right on that very first line gives you an E. You are quite literally just taking one physical step up the ladder and one step forward in the alphabet. Simple, right? And moving right along, the very next step, jumping from that first line into the first space, gives you an F. We are just rapidly climbing the ladder here. It's a continuous alternating pattern, line, space, line, space. So, following this exact same logic, the second line is a G, the second space is an A, the third line is a B, and so on, all the way up to the F on the top fifth line, and the G sitting right above it.
But wait, what happens when we run out of lines? Well, that's where ledger lines come in. We use these extra little lines to reach the glorious extremes of your violin, because honestly, the main 5 lines just aren't enough to contain all the notes you can play. When we need to go lower than our anchor D, we just count backward in the alphabet and add lines below. 1 ledger line down, that's a C. The space below that line is B. 2 ledger lines down and sitting right underneath that second line is your lowest note, G. And on the flip side, your high A sits on its own single ledger line right above the main staff.
Okay, Section 2, meet your violin fingerboard. Having cracked the written code, let's move over to the physical territory, where the real magic happens. The fingerboard is your literal playing field, and it is time to map our alphabet directly onto it. Consider this your Rosetta Stone. Notice the 4 open strings from low to high, G, D, A, and E. These are your absolute foundations. Now, on top of this smooth black surface, beginners typically use 3 finger tapes placed straight across. The tape furthest away from you, that's for your first finger, your index finger. The middle tape is for your second finger, and the closest tape is for your third or ring finger. Moving on to Section 3, the magic of fingers. So the absolute crucial point here is understanding how placing your fingers on these tapes literally spells out our musical alphabet. You really don't need a complex formula for this, you just need your fingers and your ABCs. Every time you drop a finger onto a tape, you advance exactly 1 letter name. Let's see how this builds physically on the G string, for example. You start open, meaning no fingers pressed down at all, and that note is G. Now, put your first finger on the first tape, the alphabet moves forward 1 letter from G, wrapping back around to A. Put your second finger down on the next tape, you get a B. Drop your third finger on the third tape, and boom, you have a C. You literally just step through the notes. And it's the exact same pattern everywhere. On the D string, it does E, F sharp, G, and so on, all the way up. But remember the physical sensation here. When you're using these standard tapes, your middle and ring fingers, so your second and third fingers, will actually touch each other on the fingerboard. They are right next door to each other. Building this physical, tactile memory is just as important as reading the ink on the page. You're basically teaching your hands to memorize the map.
Which brings us to Section 4, half steps and whole steps. Now we must introduce a super important modification to our fingers so we can capture every single note on the page.
You see, music isn't totally uniform.
the spaces between notes change, and so the spaces between our fingers have to change too. Sometimes the music calls for a low 2, which physically means dropping your middle finger down so it bumps right up against your index finger. You're going down a half step from the regular second tape. This completely changes the notes. On the G string, a low 2 gives you a B flat. On the D string, it's an F natural. On the A string, a C natural, and on the E string, a G natural. You're effectively shifting the entire layout of the alphabet right under your hand.
Let's compare this to a piano for a second, because it perfectly visualizes the tight squeeze of a half step versus the wider gap of a whole step. On a piano keyboard, a half step is the very next key, whether it's black or white. A whole step skips a key. On your violin, obviously, you don't have keys, you just have the string and your fingers, so the physical distance between your fingers acts exactly like the keys of a piano.
You can kind of think of a half step as your fingers being best friends that absolutely have to touch, like when you play that low 2 right up against your first finger. A whole step, on the other hand, means they need some polite personal space on the tapes, like the gap between your first finger tape and your standard second finger tape. Your physical hand is literally mirroring the acoustic distances of the musical scale. How cool is that?
And finally, Section 5, Connecting Staff to Strings. It is time for our final aha moment, bringing the theoretical map and the physical territory together.
We are going to lock these written notes to specific regions on your instrument. Look at how perfectly structured this is. Distinct chunks of the 5-line staff correspond directly to specific open strings on your violin. That lowest G up to our anchor D, that entire section belongs to the G string. From that anchor D up to the G on the second line is your D string territory. Then, the A string takes over up to the 4th line D, and the E string reigns supreme from the top space E upward. It is just elegantly categorized.
Returning to our master guide, you can now see exactly how the written notes climb seamlessly across your strings and finger tapes. The staff is no longer just random lines and circles on a page, it's a direct command to your fingers. A note perfectly positioned on the second line is simply your D string with 3 fingers pressing down. It becomes an instantaneous, tactile translation.
So, I'll leave you with this exciting thought to ponder as you practice. If our beginner map ends right here, hovering just above the staff with that high A, just imagine the infinite musical territory waiting for you further down the fingerboard. The math of the strings goes on forever. So, how far are you willing to reach? Keep practicing your map reading, and we'll see you in the next explainer.